Welcome to Ask and Learn.
So the domain for this function is x, it has to be greater than 0 because we can't have a 0 because of the denominator, and we can't have negative numbers because of the numerator. Intercepts, 1, 0. Symmetry, none. Asymptotes, we have one at x equals 0, again because the bottom cannot equal 0. And we also have a horizontal one because the limit as x approaches infinity of our function ln of x over x squared is 0. So we have, as x approaches infinity, we have a horizontal one at y equals 0. Okay, and next we can find the first derivative. So y prime. Y prime equals 1 minus 2 ln x over x cubed. Set that equal to 0. And we find that x equals the square root of e, which is approximately 1.6. So we have a max at 1.6 because the first derivative test tells us that 1.6. So values below 1.6 will be increasing, above will be decreasing if you test it in the first derivative. So 1.6 is a max. So, and by the way, the point is 1.6 comma 0.18 if we substitute into our original function. So 1.6, 0.18, that's our first derivative test. And now we can find our second derivative for concavity. So our second derivative is y double prime equals negative 6 ln x plus 5 over x to the power of 4. Set that equal to 0 and solve for x. So you can see that x equals e to the 5 over 6, which is approximately 2.3. Okay. And f of 2.3 is 0. Oops. F of 2.3 is about 0.15. 0.15. So our second derivative test tells us that at 2.3, if we test values into the second derivative that are smaller, we'll see it's concave down. So concave down, and then concave up if it's above 2.3. So this is an inflection point. At 2.3, comma 0.15. Okay, so that's all the information we have, and we can graph now. Okay, so we can graph our asymptotes. So we have one at x equals 0. So that's our vertical one. And we also have one at y equals 0. That's a horizontal one. So we have a intercept at 1, 0. So let's say this is 1, 1, 0. And we have a max at 1.6, so that's about here, and 0.18, so this is our max. This is just an approximate, it's a sketch. And we have, it's going to be increasing until it hits 1.6. So it's going to be increasing, go through the intercept, and once it hits 1.6, it's going to start decreasing. So now it's going to go down, but it's still going to be concave up until we hit 2.3. So let's say if this is 1, let's say that's, so 0, 1, 2, this is about 2, so 2.3 would be here. So it's going to, although it's going to decrease, it's going to still be concave down until about here where it switches to concave up, and although it's concave down, it's going to continue decreasing and approaching but never touching our asymptote.